The equation of a curve C is given by this. Find dy dx in terms of x and y. This line meets C at 2 points. What can be said about the tangents to C at these points? Justify your answer. Find the equation of the tangent at this point. Give me your answer in this form, where a, b and c are integers. So let's have a look at this then. Let's get dy dx first of all then. Oh, it's going to be an implicit function, so we can't write it down explicitly here. This is a product, so let's just differentiate it term by term throughout the equation. So this is a product, so it would be the product rule, u times dv, and this goes to naught and this differentiates to dy dx, plus v, which is y plus 4, times du, this goes to 0, this goes to 1, is equal to, differentiate this, use the power rule, 2 comes down next to the 1 less than 2, which is 1, and then something squared, power rule, 2 times something to the 1 multiplied by the something, differentiated. So that's what we've got. So let's bring this 2y dy dx through the equals and make it a minus. So we'll end up with x plus 3 minus the 2y, all lots of dy dx, is equal to, leave the 2x as is. This y plus 4 times 1 is just y plus 4, so move the y over, and then move the 4 over as well, flip the sign. So now we can write down what dy dx equals explicitly in terms of x and y. So it's 2x minus y minus 4 over x, and I'm going to write this term second, minus 2y, and then the 3 we'll write in a different order, so that's easier on the eye then. So there's dy dx, part 1, part 2. Okay, this meets C at 2 points. What can be said about these tangents? Part 2. Here, what can we say? This 2y equals x plus 3. See this? X plus 3 minus 2y, that will be 0, won't it, if you move the 2y over? So the denominator is 0. So dy dx is not defined. We choose to, in other words, dy dx is going to tend to plus or minus infinity. One of those, either of those values. So it's not defined. So tangent, the gradient will be infinite, so tangent is vertical, isn't it? It's parallel to the y-axis. Its gradient is infinite. Tangents are, because there's 2 of them, are parallel to the y-axis. Y-axis. Okay, 2. Find the tangent at 6 naught in this form. Part 3 then. 6 naught dy dx. Let's put it in. X equals 6, y equals 0, so 12 minus 0 minus the 4 divided by x, which is 6, minus 2y, which is 0, 2 noughts are 0, plus 3. 12 minus 4 is 8, 6 plus 3 is 9. So, the gradient then, y minus 0 is equal to the tangential gradient, 8/9, of x minus the value 6. Y minus 0 is just y. Move the 9 up to be with the y. 9y is equal to, so the 9's gone up and we expand the bracket, 8x minus the 48, 6 8s are 48. So we got 8x, just write that there, move the 9y over to be with it to become minus 9y, and then move the 48 over to the other side. Becomes plus 48, so that equals 48. So here A is 8, B is minus 9, and C is 48, and that's the form we wanted to write it in for the question.